So, dear students, so today we are going to discuss about the uh, digital signal processing. So, the subject is called as a digital signal processing. So, under the digital signal processing, we are going to discuss the what are the basic terms of syllabus in our digital signal processing. So, this subject having a totally 5 units. So, namely, the unit one is deals with the discrete time signals and its characteristics, whereas the unit 2 deals with the Z transform and what are the methodologies of Z transform and how to find out the inverse Z transform and what is mean by ROC and what are the different methods we are going to analyze to find the impulse response and frequency response. And for unit 3 is concerned, we are discussing about the fast Fourier transform and its types, and also we are going to discuss about the discrete convolution, and entirely we are going to discuss the how we are going to compute the DFT of the sequences by using FFT algorithm and also by using a IFFT algorithm, which means inverse fast Fourier transform. And the next one is about your unit 4. So the unit 4 and unit 5 is deals with the filter design. Namely, the unit 4 is deals with the finite impulse response filter design, whereas unit 5 deals with the infinite impulse response filter design. So under the unit 4, so we are going to discuss the different categories of FIR filter design and what are the methods of FIR filter design, like Fourier series method, windowing technique and frequency sampling method, etc. we are going to discuss. And in case of unit 4, we are going to discuss the IAR filter design. So likely we are having a different methods like approximation of derivatives, impulse invariant method, bilinear transmission method, and also we are going to discuss the different filter of analog, namely Butterworth filter and Chebyshev filter. Apart from this, we are going to discuss the realization of the analog filters like direct form 1, direct form 2, cascade and parallel realization, etc. So this is the overview of the digital signal processing syllabus. So now we are going to discuss the what is the introduction about the digital signal processing. So as we are aware of in the lower semester, what is mean by signal and what are its characteristics, what are the types of signals, everything we discussed in the previous semesters. So now we are going to discuss about the digital signal processing. So in here we are going to discuss about the introduction to digital signal processing. So digital signal processing is nothing but processing of a signals by using any kind of a system. We are going to discuss the system is namely here called as a computer. So the processing of signals by using a computer is nothing but digital signal processing. So before processing the signal, you must know the exact meaning of a signal. So signal means nothing but a detectable physical quantity or impulse. So it may be a voltage signal, current signal or magnetic field strength, etc. But anyway, the physical quantity which conveys some information or messages. So which is nothing but your signal. So a signal is a physical quantity which may be give some kind of information, so which is about your signal. So the next slide is about your what are the characteristics of signal. So signal having a different characteristics like in terms of physical quantities and physical measurable parameters, and signals are in terms of analog in nature, and signals contain some kind of information. For example, temperature. So temperatures deals with the one of signal characteristics because it gives the physical quantity of a temperature. What is a degree Celsius, or it may be what is the range of Fahrenheit. So physical quantity of a temperature we are measuring. So which one of the category? Second one is the pressure and mass, speed, acceleration, torque, voltage, current, power, energy. So all kind of is a simple example of our signals. So once again we are recalling the signal here. Signal is a physical quantity which conveys some messages. For example, we are measuring the temperature means we can call it as a temperature. We are measuring the torque means we are called it as a torque, or we are measuring the voltage or current. It may be anything. So which is the signal characteristics examples. In this case, analog signals are electrical. So as far as the electronics and communication engineers, you must aware of what is meant by analog signal, what is meant by digital signal. Everything you must aware of it. So basically the signal is having a two categories. One is analog signal and next one is a digital signal. Whereas the analog signal is called as a analog in nature, which means continuous. Whereas in case of digital signal, which is may be a discrete time signals. Okay, so the next slide is about your digital signal processes. Digital signal, how it is going to be processed, the digital signal. We are having two methods. One is the analog to digital conversion and next one is a digital to analog conversion. For ADC, we are doing the representation of a binary from the analog signals, whereas in case of DAC, we are getting a digital information from the continuous analog signal. So these are the two kind of processor available in a DSP. So the basic step in a DSP is a ADC. So what is mean by ADC? In case of ADC, initially we are getting an input signal, let it be a continuous. This is shown in a figure. The continuous signal is given to the analog low pass filter. The low pass filter we doing the filtering operation. After doing the filtering operation, the output of the low pass filter is given to the sample and hold circuit. Here we are measuring the signal as a XE of n into t. So where n represents your quantized value and capital T represents your sampling interval. So based on the continuous signal time period, it's going to be quantized. So once the quantized means the signal is entirely getting the information like x of n. So here we are getting the information x of t is quantized. After getting a quantization, we are getting the signal as a x of n. So here x of t is converted into x of n. The x of n is given to the digital signal processor system. So we will doing the processing. So this is a simple block diagram of your ADC. So second one is about your DAC, second process. So here we are giving a digital signal input and the digital signal is going to be converted into analog signal. So initially digital output signal we are getting, it may be a binary signals or digital signals, and the signal is going to be processed with the help of a D to A converter by doing a analog processor, and here we are using analog low pass filter, high pass filter, everything, or we are based on the requirement we are using the filters, and finally we are getting a continuous low pass signal or continuous signal. So here the continuous signal is called as a analog signal. So this is the second step. Once again I am repeating here, under the digital signal processing there are two steps available. One is the ADC, second one is the DAC, and the next one is about your why processing signals. What is the reason we need to process the signal? So the processing is nothing but we are going to study the characteristics, or we are going to extract the information. So we are going to extract the information. The information may be amplitude, phase, or frequency, or any spectral content. So we are going to extract the information in terms of amplitude, phase, frequency, etc. So generally while doing the processing of signals, we are having a different methods like generate from feedback control signal, transforming the signals, extracting of signals from noise sources, and compress data and store signals in a digital format for analysis. So we are under the 6 headings, we are having a different methodologies and different parameters. Okay, and the next one is about the typical architecture of a DSP system. So what is the basic architecture we are using in a system? One is about your the analog system, and next one is about your DSP system, analog signal processing. Second one is about digital signal processing. Under the analog signal processing, initially we are getting a sensor. The sensor going to be sense the input value, and the input value is given to the analog signal conditioning. After doing all the process which given to the digital signal processing, here the first is steps of digital signal processing is the ADC. The ADC output is given to the digital signal conditioning or digital signal processor. So the processor will do entire performance or entire process. It's going to be digitize all the data from the analog signal output. So finally we are getting a analog output. So this is the typical architecture system. So from the analog signal processing we are converting into exactly DA system, and finally once again we are getting the analog signal from with the help of a digital to analog converter. And next one is about your exact meaning of signal processing. So human has the most advanced signal processes like speech and pattern recognition, speech synthesis. So we are encounter many types of signals in various applications like electrical signals, voltage signals, current signals, magnetic and electric fields. So from this part we are going to extract the information. You need mechanical signals like velocity or speed or displacement. You have to get the extraction from the mechanical signals, or you are going to extract the information for a sound and vibration, means the source is about your acoustic signals. Likewise, we are going to extract the signals. So once again, the signal processing is nothing but extracting the signal characteristics or studying the signal behavior. Okay, so we are having a different processor in case of different requirements from the devices like analog circuits. You may be any type of systems, maybe a processing of a system with the help of ADC, processing of a system with the help of a DAC. Okay, and next one is about your limitations. What are the limitations of analog signal processing? So there is a simple different limitations available. So here, due to the component tolerances and undesired non-linearities, there is a limitation of accuracy. So due to this, there is some limitations available in accuracy, so we can't get the 100% efficiency. So little bit there is a deficiency while getting the exact accuracy. And also we are having a simple limited repeatability due to the changes in environmental conditions like temperature and vibrations. And also it is a sensible to the electrical noises. Due to the noise sources is going to be sensed in the different parameters, so the system leads to the failure and inflexibility in changes and difficult of implementing certain operations like non-linear and time varying factors. So there is these are some limitations of your analog signal processing. So the next slide is about your exact meaning of digital signal processing. So now you are getting an exact meaning of digital signal processing. So digital signal processing is nothing but representing signals by in terms of a sequence of numbers by digital conversions. So initially you have to get the information from analog to digital converter. The analog output of analog digital to convert is given to the DSP processor system. So here the DSP process system is going to be extract the information from the ADC, and finally we are going to give it to the DAC. Here the purpose of DAC is to reconstruct the signals. So once again we are getting an analog signal. What are the signals we are going to given as an analog input? The same signals we are going to get it in output with the help of a reconstructing filters. So here analog input we are giving and analog output we are measuring. Example, digital recording of a music. And analog input and digital output means touch tone and phone dialing. We are giving analog input and digital output. The perfect example is touch tone and phone dialing. So in case of digital input and an analog input output means text to speech conversion. So these are the simple examples. And also digital input, analog output, digital input and digital output means compression of a file on a computer. So nowadays we are using in a fourth category, digital input and digital output, compression of a file on a computer. So these are the simple digital signal processing systems, and where we are going to use in a DSP. So DSP is always run all the applications like sound applications, communications, automotive applications, medical applications, military applications, image and video applications, as well as mechanical applications. So DSP is used in everywhere in the day-to-day life. Without the digital signal processing, we are not available to use the mobile communication applications. Okay, and the next one is about your digital telephone communication systems. So this is a simple example of your digital telephone communication system, and initially we are giving a digital normal text signal as a input. The digital signal normal speech signal or text signal is converted into A to D, measured as analog waveform, and the analog waveform is given to the A to D converter, and we are doing the performance parameters like analyzing and quantization, and after doing analyzing and quantization we are given to the encoding process. So here the data is going to be encode like different patterns like binary zeros. After doing the encryption we are going to give it to the modulate or modem. So this block is entirely called as a transmitting telephone. After that we are going to give it to the receiving telephone system. So here the analog output, the binary outputs of a modem is given to the input to the telephone channel, and the input of the digital telephone channel is given to the demodulator unit. Here the demodulation performance is used in the and scramble and decoding purpose and synthesis process, and finally we are getting a given to the digital to analog converter, and finally we are getting a receiving the signal. So these are the parameters like in a simple digital telephone communication system. So transmitting a telephone signals and receiving a telephone signal. So this is a simple example of your digital telephone communication system example. Okay, and so this is a simple DSB meaning of your digital signal processing and what are the basic systems and how we are going to remember this signal processing system is another this topic we covered. So today we will discuss what is the meaning of signal and what is the meaning of digital signal processing, what are the two kind of digital signal processing and what are the basic examples. So remaining topic will be discussed next class. Thank you all.